Thank you, Paul. Hi, everyone. You're the lucky one that made it in. I feel privileged to have this opportunity to introduce this new platform. Great platform, as Paul said. But before I dive into it, let me start with a quick scan of the environment. So, fasten your seatbelts and enjoy the ride. Today, we are selling 1 million PCs every day. Yes, 1 million PCs every day. And it's not luxury, it's necessity. But the customer of these PCs are changing. And the change is dramatic, is accelerating, and it has a major impact on our ecosystem. While the overall market is growing, the major driver for this growth is the consumer. The consumer percentage of the total pie, and I'm speaking notebook in this case, is growing from 29% in the year 2000 all the way to 66% today. What a phenomenal growth. So, if the world is moving from business enterprise to consumer, I believe it will be fair to say that consumer is a king. And because I'm in the US, I have to be politically correct, and I've got some legal people over here. Definitely I'll say it's also a queen. I need to be safe. So, it's definitely a totally new world for internet for all of us. When you speak with business, when you speak with enterprise, you speak to the brain. When you speak with consumer, you speak to the heart. Enterprise buys something because they need it. Consumer buys something because they want it. And the question is, do they want it? And the answer is yes, a big yes. And yes, I read all the articles on the web in the last year about growing and not growing. Guys, the CEA, the Consumer Electronic Association, the same one that is running CES, made a survey of the holiday consumer electronic wish list. Notebook and laptop hit the top of the wish list, 3rd year in a row. Position number 2, position number 3 changed. The first position haven't changed, and now we need to argue what we'll see next year. But why is it the case? Let's see how we live our lives. 2 billion people on the internet. It's true, it's only 4th person, but let's admit it. We are hooked to the internet. We are watching our email almost all day long. We cannot imagine the world without the internet. And what are we doing when we are on the internet? Yes, we are doing emails. The new spot in time. 247 billion emails a day. Can you imagine? 247 billion emails a day. By the way, 8 out of 10 are spam. So let's get rid of them. And the other 2 out of 10, I believe, end up in my inbox. And I believe many of you are sharing the same feeling. So it's not 247 billion, it's only 50 billion that people actually read. But definitely huge amount of traffic on the internet. But that's not where it ends. 2 billion videos viewed every day on YouTube alone. That's content consumption. But at the same time, and people do not know about it, people upload more than 2 million minutes of video every day. That's content creation. And I'll come to it later on, because there's a confusion if people like to do consumption or creation. They like to do both, and I'll speak about it. If you look at the pictures, last but not least, 2.5 billion photos are uploaded every month to Facebook alone. And again, I don't have the statistic of Tencent and all the other social networking. 2.5 billion. And those of you who look at the tweets, 24 hours ago, Randy Zuckerberg, the sister of the famous Mark Zuckerberg, on New Year Eve only, in the 2 days, people uploaded 750 million pictures. Why do I tell you all of this? Because at the end of the day, people used to communicate with text. Today, people communicate with pictures and with video. And not simple picture, not 2 megapixels, 10 megapixels, and 15 megapixels, and not standard video, high definition video. And the demand is going up, and that's what we'll try to answer. So, it's all about consumption and creation of digital content, And we in Intel need to develop the technology to facilitate and enable this great user experience. And you see me repeating this word several times today. It's about user experience. But you also need, and I'll prove it to you, the performance underneath it. Not performance for the sake of performance for the sake of delivering this great user experience that every person will be able to use it without being a geek or computer hacker. But he will need the performance to deliver this great experience. And by the way, don't buy the story of people like to consume, people like to create. People don't like to create, people just like to consume. People like to create. People like to be innovative. The only problem is it's very complicated. If you remember 10 years old, 10 years ago, if somebody had red eye, you need to go to something complicated to get rid of it. Today, everybody's cleaning it. That's creation. And I believe if we'll be able to deliver a simple way to do it, people will create more and more because it's in our blood and that's what we like to do. And remember the amount of material that we upload to the internet, that's creation. And this is what we try to deliver. Our sixth generation core processors, codenamed Sandy Bridge, were developed to address these challenges. And Paul spoke about quicksync and stuff like that. It looks trivial today, guys. It was not trivial 4 years ago when we tried to define what are going to be the usages in 2010. And this is something that they developed to predict 4 years ago. So simply put it, if we look at all the features, Sandy Bridge is visibly smart. It's a combination of smart performance, performance on demand, this famous turbo, with stunning visual experience. And I'll touch on it and I'll show it. It's revolution, and from technology point of view, I agree with Paul, it's masterpiece, and it's the biggest step function I've seen in Intel since I joined Intel. I believe it will be a cornerstone of the computer revolution, and we'll hear about it many years when we move forward. So give me 3 minutes of bragging. Sandy Bridge is the first mainstream microprocessor that integrates the CPU, the graphic, and the media on our 32 nanometer technology. On the core side, we have between 2 to 4 core, low power, high performance, performance on demand cores, which have got huge amount of innovation inside, but this will be covered in the technical speeches, not in the introduction. So these are the cores that you see over here. Here you see 4 cores. The second part is the processor graphics. The processor graphics is responsible for the 3D and the media together. We've got special dedicated media accelerated inside. And for the same time, as people say, it's the first time that we've got high definition graphic on the most new technology like the microprocessor. It's enabled us to put many more transistors, lots more functionality, much higher frequency, at the same time low leakage. Excellent solution in order to be able to do it. I'll show you some of the amazing benefit in a few minutes when we'll go and look at it. We've got a shared, level 3 shared cache. Only 460 million transistors. And people ask me, what is the shared cache? Is it part of the core or is it part of the processor graphics? And the answer is yes. It's part of the core, it's part of the processor graphic, and once we integrate everything on the same chip, you'll see that there are quite a few resources that everybody is using other resources in order to be more effective, in order to give better performance and responsiveness, and in order to reduce the power consumption. So, the last unit is definitely the way to communicate with the external world. This is the system agent. This is the I/O, our ears, eyes, hands, that are responsible for the DMI, for the display, and the rest of the I/O. These are all the components of Sandy Bridge. Overall, Sandy Bridge have got 1.16 billion transistors on a chip. Guys, I would like to repeat it. 1.16 billion is a big number. So what you see over here is 1.16 billion transistors. Just to put things in perspective, if you take one human hair, the diameter of the human hair, if you put it on this die, will cover 2,500 transistors under one human hair. Now, all of you know Moore's law, 1.16 billion transistors. Most of you, the average, the smart one, you've got 100 million neurons in your brains. So if you look at Moore's law, pretty soon we are going to go after you. So I don't want to scare anybody, but guys, over here, I've got more transistors than most of you have got in your brain. So again, if you look at Moore's law, we've got 1.16 billion transistors, but pretty soon we'll be able to increase the performance, the experience, and the things that you are going to see with this. So, I thought that I will not speak about benchmarks. I say I'll skip it. But you know, the device is so good, the microprocessor is so great that I couldn't resist the temptation. So rather than take you to 10, 15 benchmarks, let me just take you through that most of you. Just playing Excel spreadsheet. The new core, the second generation core, Sandy Bridge, is outperforming the best microprocessor in the world until yesterday by 60%. Our current generation is 60% faster than the best microprocessor yesterday. And if you look at creating presentations or some basic creation, we are going to be 62% better than previous generation. We're just doing a slideshow. 60% for one generation to another generation. But when somebody's buying to buy a new computer, normally it's not the one that have got last generation, it's somebody who got it 3.5 years. If you compare the performance of Sandy Bridge to 3 years old computer like Part.2 Duo, this is the numbers that you'll see. You'll see 800% faster when you are trying to run Excel spreadsheet, or 300% when you are trying to do slideshow. Now, can you see the difference? Guys, you will see the difference. And it's not about the performance, it's about user experience, about the responsiveness. It's about how fast you'll be able to do things. And guys, the minute you'll be able to use to this, you'll never be able to even watch or go back here. So you're ours. But definitely we need to make sure that you practice it. But it's amazing, and I fully support what Paul said. Yes, we did it, etc. But this is really a step function in the microprocessor design, and I believe this is something phenomenal. Okay, I'm already 10 minutes into my presentation, and we didn't do any demos. So let's go and look some demos. Hi, Marley. Why don't we start the demos, and while the demos are running, let's speak about it. So the count of 3 or whatever you want to count. Okay. Why don't you start the demos?
All right, we've got the demo started. Actually, what we're going to show is a little bit of a performance demo, and we're running an application called Cinebench that allows us to show the threading performance of these 3 different systems.
So the first one is synthetic. In a moment, we'll go to most user-friendly, but actually Cinebench, it's utilized 100% of the performance that every microprocessor can have, and we've got 3 systems. The left system
is the second generation Core i7.
Sandy Bridge, the middle one.
The middle one is last year's Core, previous generation.
The best microprocessor in the world until today. This is the middle one. And the right one
is the 3-year-old Core 2 Duo system.
Okay, so what we see over here is that we are rendering a 3D pictures. We can see on the widget the turbo, so we see that all the systems are running in turbo mode in order to deliver performance on demand. And the idea, finish the task as fast as possible, deliver back the response, go to sleep, and save power. And indeed, you can see that the system on the left is pretty soon going to finish it. You can look at the turbo widget, 2.6 gigahertz, and you see the minute it will finish, it will drop down the frequency, go to sleep, and start saving battery life. I believe we're going to be there pretty soon. It's green. By the way, you can have this widget, definitely technology friendly. And if you look at the middle, you see the system is still working. This is the last year system, and if I look at 3 years old system, you can imagine how much time you need to wait. But this is synthetic. Can you show me something which is kind of more user experience?
Yeah, something that would be a more everyday usage model. So why don't we pull up an application called Lightroom. It's a sort of a prosumer image editing application. And what we're going to do is we're going to go ahead and fire off a filter on a set of images, and it's going to basically do some retouching of the photos to kind of improve these portraits.
So look at the bars. The bars show you how fast it's done. He called it filters and all this kind of thing. Guys, you take a face and you just try to make it more beautiful. It's the same way they used to have an eye. We want to get rid of a red eye. Here we are trying to get a face and beautify it have a better memories of ourselves. Sandy Bridge system already finished, the other one is still working. Can you show us side by side? Look at this and look at this. This was done real time, as you've seen, in order to try to go, and it's complicated because not only that's beautifying the face, when you look at your eyelashes, hair, etc., it needs to know not to touch it. Actually, I believe it's impressive, no? Ladies, I want to hear you. But
Really?
the lawyers will ignore this. The truth of the matter, I wanted to use it and say, can you beautify my face? But the comment was that he needs to wait for the next generation of CES. So I came up and I promised to remind him during the ranking and rating session. All right, let's go on. Let's look at photo and video management. We say that today, we collectively look at our history in some emails, but mainly photos and videos. And the problem is, how can we find them? You know, I've got these piles of photos and videos from my son bar mitzvah, for my trip to the Philippines, or to Vietnam, or to Myanmar, or whatever. And here we've got another. How do you find it? I remember I have it someplace. And the idea was, let's try to repeat the way that our mind works. And the way that we look at our history is through lenses. We look at the faces. Yes, I remember that I met my wife there, and it's about my wife. Remember by places, you know, I was in India, and we remember dates. You know, in 1977, I remember that. It's faces, it's places, and it's dates. And we say, let's try to see if we can manage all this huge database that we've got, and this database is growing because you've seen the number of pictures that we upload. Can we manage it in a nice way? The required performance is huge, but the end user should not be aware of it, needs only to look at the experience. So what we have over here is a software that we developed in order to look into it. And what we see over here, if they'll screen it, yeah, we can see that this is the way that our memory works. This is the places, this is the calendar, and this is the faces. First of all, let me try to remember I was in Myanmar. So I'm going to Myanmar, and let me try to look into it. And it was February 2007, and yes, I see something I remember. I don't need the map anymore, let's get rid of the map. And we can see it. We can see these places and going and see the exact locations. Now, I remember also that in 2007, and now I do not speak about places, I was somewhere climbing in Machu Picchu. I can look at 2007, I can look at June timeframe. I open June timeframe. Everybody can see Machu Picchu over here, but I would highly recommend it. Come in on the Linka, it's a very nice trail. But over there was a beautiful carnival, and I remember that I shot a beautiful clip. So I'm trying to look into it, and when I'll try to look into it, you'll see that I can stream more than 60 videos at the same time over to the screen. Guys, we are speaking user experience, but you need Sandy Bridge class of performance in order to try to deliver it. And without going into any detail, I believe there are many devices that will not be able to do it. And yes, this is the clip that I was looking for. Let me open the clip. And now we can look at it. This is the thing that I was looking in order to be able to watch it and enjoy it. So this is the calendar. And as I said before, this is the places, the location. This is when I try to show you the places that I was in Myanmar, which is not very friendly to me, but eventually it will do it, yes. And we go, and this is again that I showed. I go by places, by the map, and again, this is Bagan, the beautiful places with the temple, and again, you can look into it. So the idea remains, let's give the performance, or let's deliver the experience that once you're looking for something, you can look it based on location, based on faces, or based on places, and now it's trivial to do it, but you need a lot of performance in order to be able to deliver this great experience. Another technology that we mentioned is quick sync video. Again, I remember 4.5 years ago, somebody had to come and say, guys, we are going to exchange files between different devices, and while doing it, we need to do transcoding. So again, let me ask you a question. How many people here are using transcoding? Raise your hand. How many people here are not using transcoding? Raise your hand. It's okay, don't be ashamed, it's happening. Okay, how many people are downloading music or video from the PC to their iPhone or iPod? Raise your hand. Surprise, this is transcoding. You take one format, in this case MPEG, and you change it to H.264, but it doesn't matter for consumer, it just downloaded. How many people take a 3D or 2D video with a Sony camcorder and download it to the PC? Raise your hand. That's transcoding. Because Sony is done in one format, you need to change the format to encode and decode. This is transcoding. We believe that it will be pervasive, people will use it a lot, and for that reason say, is there any way to accelerate it? And when we speak about accelerating transcoding, we are not speaking about 1x, 2x, 3x, or 4x. In March, I was in Vietnam, I took 1 hour pictures with my video camcorder. It took me 1 hour to download it. I don't have the time, I want to do it in 10 minutes, I want to do it faster. And the challenge to the team was, can you do it 10 times faster? And the answer for the team, yes. It will be a challenge, but we can do it. So what we have over here is a system, let's look at the system, of two systems side by side doing transcoding. One system is here, the other system is here. So I want to start the transcoding, and let's try to transcode it. In a nutshell, let's take a file from our PC and try to translate it to a format that we can put in our iPhone. You can see how fast it's going. Look at the bar. You can see the green bar. You can see how fast this is going, and you can see the other one. This will take us, this is going 345 frames per second. This can do hardly half, 136 frames per second. This is already done in 17 minutes. This is already working. But this is not the interesting thing. The interesting thing is that I didn't compare this PC to this PC. Don't look at the screen, look at me. I compared this PC to this notebook with processor graphic. So here, the transcoding was done with the Sandy Bridge processor graphic, and here, this was done with a honky big discrete graphic card, which cost more than $400. And I believe it will be safe to say, guys, that today Sandy Bridge is probably doing transcoding faster than any discrete graphic card in the market. This is the place that I need to be quiet, and you all need to say, wow! I really need to hear developers, the designer of Sandy Bridge, are sitting in the first row. So I'll help you. 1, 2, 3. Wow. Thank you. Now I can go on. So this is the QuickSync technology, transcoding from one format to another format. I believe you'll see numbers which are 5, 6, 7, 8, and 10x. And the president Togetti had the chance to play with this. This is one of the things that they highlighted. I believe we caught everybody by surprise, because this is really a usage model that we're trying to move the files between the device to enjoy the content. This is exactly what's going to be behind it. Now, I've searched